Hello, class. This is the second part of our capacitance presentation, so FRQs. As you can see, I'm Ayon Man, and that's Somosa, and this is a nice meme for all of you to enjoy. So, so our first question or our first part, because our topic isn't really that much discussed in AP, so we had to divide it up into parts. So our first part is from the 2007 AP or Form B of the 2007 AP, and it's Part C. But in order to do Part C, we also have to find Part A. So first off, when we find Part A, it's asking for what is it? It's asking for the current in the 500 ohm resistor. So to find that, we just had to find the total resistance. We just had to find the total resistance, and since they're in series, we add up and we get 1500 ohms. And then I equals voltage over resistance, which equals 8 times 10 to the negative 3 amperes. So now our part, which is about capacitance, so charge stored on the capacitor, we're going to need one variable. We're going to need Q equals CV to find the charge. So in order to find, so we already know that capacitance is given, so 30 times 10 to the negative 6 farads. So what we have to do is find voltage. So as you can see here in the circuit, the resistor and the capacitance are in parallel, which means that they're going to have the same voltage drop. So as long as you find the voltage for this resistance, you can pretty much figure out the charge on the capacitor. So to do that, we use V equals IR again. We know from A that I is 8 times 10 to the negative 3. We know R is, of course, 500 ohms. So that means it's 4 volts. Plug that in, Q equals CV. You get Q equals 1.2 times 10 to the negative 10 to the negative coulombs. So for this question, you get 1 point if you just use the formula, if you just write it out. You get another if you use V equals IR to find the voltage, and you get another if you plug in to this formula that you found. So it's kind of an easy way to get points if you know what you're doing, but you had to identify a few things in the circuit itself. This question, the reason we included all these parts is because you need each part, so A, B, and C, to figure out D, which is what we're trying to figure, which is the part we're trying to discuss. So again, charge stored on one plate of the 6 microfarad capacitor. So to find that, we have to do A first, so total capacitance. To do that, you have to recognize that they're in series, which means that we use this formula. And once you do that, you substitute in the values of the capacitance. You get the total capacitance is equal to 4 microfarads, and that'll get you 3 points. So then we do B, and B is asking for the current in the 10 ohm resistor. So to do that, we have to recognize first that since the circuit's been connected a long time, that each of these capacitors are going to be fully charged. And from RC circuits, we know that means right here that current only flows through the resistors if the capacitance is fully charged. So all we have to do now is find the total resistance, use V equals IR to find the current. And once you do that, you get 0.2 amperes. That also gets you 3 points. And now C asks for the potential difference between A and B. So to do that, we have to find the voltage across the 20 ohm resistor, since the capacitors are in parallel with the 20 ohm. And we know that the voltage drop is the same from the last problem. So to do that again, we use V equals IR, and V equals 4 volts. So it's kind of getting repetitive, but you get the idea here. We're just finding the necessary variables we need for part D. So part D again asks charge stored. We use Q equals CV, C from part A, V from part C, which we got from finding I in part B. So you substitute those in, you get 16 times 10 to the negative 6 micro coulombs, and that is going to get you 4 points if you use the variables, plug them in, use the values you found from the other parts. So again, it's kind of an easy way to get points if you know what you're doing in the other parts. But again, to do that, you need you need to know a few things about circuits.
All right, for part C, this was a perfect representation of what we spoke about in the review video. And we just have to use the capacitance equation, which is the permittivity of space times the area over distance. And they give you everything you need because obviously the permittivity of space is a constant, 8.85 times 10 to the negative 12, and in the units. And in the meters, the area is given to you here, 0.3 meters squared. You just plug that in for area, and then the distance is given to you right here. And the 2 times 10 to the negative second meters is also equal to 0.02 meters. And then you just plug it into your calculator and you get 1.3 times 10 to the negative 10 farads. Pretty simple. And for the last one we have here, it's a little bit more, not complicated, but there's no numbers, so it's just kind of like a more conceptual than the other one. And basically, you have to first, there are 2 points here they have to get. And the first point is for either, you have to have a calculation that shows that either the potential difference is cut in half once there's a new capacitor once there's 2 capacitors in the circuit instead of 1, or which is the one that I actually like, is that the equivalent capacitance of the new circuit is 1/2 the capacitance of the original circuit. So here, what this basically means is that every time you add another capacitor to the total capacitance, which is the equivalent capacitance, it keeps cutting and it keeps getting smaller. So in the first part is obviously you have to use the energy equation, because remember how we showed you 3 in the review video? We have to use one of them, which is U equals half CV squared, and then the V is the EMF. So don't be confused by that. That's just basically a V. Just think about that as a V. That's the first equation for the first capacitor, which is U1, obviously. I said obviously, it's not obvious. And then the U2, it's basically the same exact thing, but you have to take in consideration that there's a new capacitor. So now there's 2 capacitors, meaning that the total capacitance is cut in half, which is what this comes into play right here, C over 2. That's where this first point is really important, because then you have to use that into this equation. And you simplify this, you basically get CV squared, or C EMF squared, over 4. And after this, you just put U1 over U2, and then just find the ratio, which is, in this case, scenario 2.
Yeah, we say this is an extra problem, but like it's probably more relevant because it's actually part of like physics 2 curriculum. Like it came from the physics 2 curriculum rather than the one before. But like, yeah, it's more conceptual, but it kind of comes down to the same thing, just finding a ratio. So yeah. And then the last part. So since both of these problems went over things like RC circuits and capacitance in series and parallel, these are some good like videos you can use to get a like refresher on them, because as long as you kind of know those 2 topics, as well as the formulas for capacitance, you should be able to get those like points for those kind of questions if they ever do appear. But like on the new ones, like on the new APs, I wouldn't really expect it to, but you don't really know. And yeah, that's our presentation.